Hello friends, welcome to the video lecture series of differential equation. In previous video, we discussed reducible to exact differential equation. When the differential equation is homogeneous differential equation, it can be converted into exact differential equation using multiplying factor or integrating factor is 1 by mx plus n, where m is the coefficient of dx and n is coefficient of dy in equation of the form m dx plus n dy equals 0. The next integrating factor we studied, that is 1 by mx minus ny. This integrating factor formula is used when equation or given differential equation is of the type f1 xy y dx plus f2 xy x dy equals 0, where f1 xy and f2 xy are the function of x into y. Now the next integrating factor formula we are going to study to convert given differential equation into the exact differential equation. Now the formula is, in a differential equation, m dx plus n dy equal to 0 is the differential equation. If fx equals del m by del y minus del n by del x by n, and for convenience I am letting it by fx. Fx equal to this is a function of x alone or a constant. A constant can be treated as a function of x. Then the integrating factor formula is e power integral of fx with respect to x. So for this, what is the condition of using this formula? Fx must be the function of x alone or a constant. Let us see the problem. Solve dy by dx equals x square plus y square plus 1 by 2xy. Now, the differential equation in this differential type of the differential equation is not given. Here, 1 by mx plus ny formula we cannot use because this is not homogeneous differential equation. Its degree of each and every term is not degree of first term is 2, degree of second term is 2 and degree of third term is 0. So this is not homogeneous. This differential equation is not of the type f1 xy y dx plus f2 xy x dy. Then I am going to check whether this fx, first of all, I am going to write given differential equation in the form x m dx plus n dy. I am cross multiplication, as I am doing cross multiplication here, 2xy dy, and dy term I am shifting on the left hand side. This means x square plus y square plus 1 dx minus 2xy dy equals 0. Now this is, I have written in terms of m dx plus n dy. Here m is what? M is coefficient of dx, n is coefficient of dy, and del m by del y and del n by del x are required. Del m by del y, derivative of x square with respect to y is 0, derivative of y square with respect to y is 2y, and derivative of 1 with respect to y is 0. Del n by del x I am going to find. Derivative of x with respect to x is 1 and minus 2y is multiplicative constant, because we are taking partial derivative with respect to x, means we have to keep y constant while taking derivative with respect to x. So del m by del y and del n by del x are not same. Therefore, this is not exact differential equation. This differential equation, this equation 1 is not exact. Okay, therefore, 1 is not an exact differential equation. It is not an exact differential equation, then we have some integrating factor formula or multiplying factor formula. 1 by mx plus ny we cannot use because this differential equation is not homogeneous. 1 by mx minus ny we cannot use because this differential equation is not of the type f1 xy y dx plus f2 xy x dy. Now, I am going to check whether fx is a function of x alone. The fx equals what? Fx equals del m by del y. Writing directly, del m by del y is 2y, del n by del x is minus 2y, this divided by n, and n is minus 2x. Okay, let us find the value of fx here. This is 2y plus 2y is 4y and minus 2xy as it is. This y will disappear, 2 by 4 by 2 is 2, 2 by x with negative sign. See, we found value of fx. The value of fx is minus 2 by x, and it is a function of, this is the function of x alone. This y is absent there, function of x alone. If fx is a function of x alone, then we can use this integrating factor formula. Integrating factor is e power integral of fx with respect to x. Value of fx is minus 2 by x. We are integrating with respect to x. E power minus 2 is outside of integral, and integral of 1 by x is log x. Then by law of logarithm, this minus 2 can be brought at the index place of the argument of log. Here I am writing log of x to the power minus 2, and log and e will disappear, x power minus 2, and therefore this is 1 by x square. So 1 by x square is an integrating factor. Okay, this integrating factor may be asked in the examination as an MCQ. As an MCQ, this integrating factor for the differential equation may be asked. Now, once you get integrating factor, then multiply equation 1 by integrating factor. Multiply equation 1 by integrating factor. If you multiply equation 1 by integrating factor, then equation 1 becomes, I am multiplying this by integrating factor. You can write down the direct steps also. I am writing indirectly because this is our first problem of this type. 1 by x square minus 2xy is multiply equation 1 by integrating factor. Now try to evaluate it. X square by, therefore x square by x square is 1, y square by x square is there, 1 by x square is there. Then multiply this by 1 by x square, means minus of 2y by x will remain. If you multiply this by integrating factor, then this resulting equation is an exact differential equation. Therefore, equation 2, this implies equation 2 is an exact differential equation. See, this is not exact differential equation. Del m by del y is not equal to del m by x. But once you multiply given equation by correct integrating factor, then resulting equation, differential equation will be exact differential equation. You can check it. But see, this is m. I am calling this as small m, and this is small m. Here capital M and capital M. Del m by del y is what? 2y by x square, and del n by del x is again 2y by x square, because derivative of minus 1 by x with respect to x is plus 1 by x square. Now, this is an exact equation, but no need to check whether it is exact or not. Now, this is exact differential equation. How do you find out solution of differential equation? Solution of differential equation 2. How to find out? Integral of m with respect to x, keeping y constant, and terms in n which are free from x. Okay, sufficient practice we have done on the exact differential equation. This is equal to c. Now this is the solution format of exact differential equation. This c is integration constant. Now integral, keeping y constant, I have to take integral. M is 1 plus y square by x square plus 1 by x square dx, and the n containing single term minus 2y by x, and that term contains x, means in n there is no term in y free from x, means we can write here no means 0 term in n which is free from x. There is 0 term, means no term in n which is free from x. Now finally take integration with respect to x, keeping y constant. Integral of 1 with respect to x is x. Integral of 1 by x square is, y square is multiplicative constant. I have to keep y constant. Integral of minus 1 by x square is minus 1 by x minus 1 by x. Integral of x raised to minus 2 is x raised to minus 2 plus 1 by minus 2 plus 1, like that. Integral of 1 by x square, integral of 1 by x square is what? Minus 1 by x square is minus 1 by x, and it is equal to c, because integral of 0 is 0. So this is the solution of this differential equation. Solution of this differential equation, or this differential equation, or this differential equation. In this way we have solved this problem. Online examination, you may be given differential equation, integrating factor, and you may be asked to find out solution. In that case, integrating factor will be provided to you, differential equation will be given to you, and solution will be asked as an MCQ. Now, the next problem, the same one. Here, we are going to solve x minus y square dx plus 2xy dy equal to 0. Okay, this is the standard form, m dx plus n dy equal to 0. Del m by del y I am going to write here is derivative of m with respect to y. Derivative of x with respect to y is 0. Derivative of minus y square is minus 2y. Derivative of n with respect to x. See, n is 2xy. Derivative of 2xy with respect to x is 2y. Okay, del m by del y is not equal to del n by del x. Therefore, this implies given equation 1 is not exact. Okay, 1 is not exact differential equation. If equation 1 is not exact differential equation, then we can convert it into exact differential equation using integrating factor. There, multiplying factor or integrating factor. So we have formula 1 by mx plus n by 1 by mx minus ny. Then this formula is also added, e to the power integral fx. This equation is not homogeneous because degree of each and every term is not same. Degree of this term is 1, degree of this term is 2. Degree of each and every term is not same. This is not homogeneous. This equation is not of the type f1 xy y dx plus f2 xy x dy, because in that case we want the y dx term and x dy term, and in each term then index of x or power of x and power of y is same. So 1 by mx minus ny we cannot use. Now we are going to check whether fx is a function of x alone or not. The fx is what? Del m by del y minus del n by del x, this divided by 2xy, and now it is minus 4y by 2xy, and the same situation is there. Here also 4y by 2xy, the same thing we have. Now it is minus 2 by x. Okay, fx is minus 2 by x, therefore integrating factor, in this problem fx is same, here also fx is same, therefore I am not going to repeat this portion. The integrating factor I am writing directly, 1 by x square. This integrating factor may be asked in the examination. Here in this case, integrating factor is 1 by x square. In this problem, we have same integrating factor. Now multiply equation 1 by integrating factor. Multiply given equation by integrating factor. If you multiply this by integrating factor, what will happen? So 1 by x square multiplied by 1x minus y square, and 1 by x square multiplied by 2xy dy equals 0. Now have a multiplication. X by x square is 1 by x minus y square by x square dx as it is. Here 2y by x, the 1x has gone. Now after multiplying given equation by integrating factor, then the resulting equation is an exact equation. exact differential equation. Now, for exact differential equation, solution you can easily find out. Solution of differential equation is what? Integral m. This is m, small m, this is small l. Integral of m with respect to x, keeping y constant, and the terms in n which are free from x. Terms in n free from x or does not contain x. In next formula, I will not be writing this formula. Now, integral of m keeping y constant with respect to x, that I have to perform. Now, integral terms in n is 2y by x, small n is 2y by x. This n containing single term and it contains x, means there is no term in n free from x, means there is zero term in n free from x. Integral of 1 by x with respect to x is log x. Integral of minus 1 by x square is 1 by x. Directly writing y square as it is, and integral of minus 1 by x square with respect to x is 1 by x. Integral of 0 is 0 and c is integration constant which is there on the right hand side. So this is solution to this differential equation. Yeah, as I said earlier, integrating factor may be asked as an MCQ, and when integrating factor is given and differential equation is given, the solution may be asked as an MCQ. Now, the next problem, third one, solve y plus y cube by 3 plus x square by 2 dx plus x plus xy square by 4 dy equals 6. This is our n. This is of n. Del m by this. Initially we use capital M and capital M and then small m, small m. Del m by del y. Take derivative very carefully with respect to y. Derivative of y is 1. Derivative of y cube is 3y square with respect to y, and 3y square by 3 is y square. Derivative of x square by 2 is 0 with respect to y, because we are taking partial derivative. When you take partial derivative with respect to y, then x terms are constant and derivative of constant is 0. Del n by del x I am writing derivative of n with respect to x. 1 by 4 is multiplicative constant and derivative of x with respect to x is 1, derivative of x with respect to x is 1, y square is multiplicative constant. The del m by del y is 1 plus x y square, del n by del x is 1 by 4, 1 plus y square. These two are not same. Therefore, equation 1 is not an exact differential equation. Implies 1 is not an exact differential equation. If it is not exact differential equation, use integrating factor formula. 1 by mx plus ny formula you cannot use because degree of each and every term is not same. Degree of this term is 1, degree of this term is 3. This equation is not of the type f1 xy y dx plus f2 xy x dy. Means 1 by mx minus ny we cannot use. Now, the fx I am going to check whether it is a function of x alone or not. It is del m by del y, del m minus del m by del x. I am increasing the speed now. This del m by del y is 1 plus y square minus 1 by 4, 1 plus y square is divided by n is x plus xy square by 4. Now, try to simplify fx fully. With some cancellations are there, just you have to perform, and some multiplication, cancellation, whatever. Now, 1 plus y square minus 1 by 4, 1 plus y square means 1 minus 1 by 4. Here 1 minus 1 by 4, directly writing 1 minus 1 by 4 is what? 3 by 4. So this is 3 by 4 1 plus y square divided by x is common here. Because if anything is common, just you take it common. This 4 gets cancelled here. 1 plus y square will be out. Then what will remain? Only 3 by x will remain. The fx, the final value of fx is 3 by x. And it is a function of x alone. Function of x alone. If fx is a function of x alone, then integrating factor e power integral of fx with respect to x we can use. This integrating factor you can use. Integral of value of fx I am putting. Then if the word 3 is outside, integral of 1 by x is log x. Then e and log will disappear. This 3 will come at the index place of x. And e and log will be removed. Okay, in this way, integrating factor will be formed. The integrating factor differential equation you will be given, and integrating factor will be asked as an MCQ. Now, multiply given differential equation by integrating factor. Multiply equation 1 by integrating factor. If you multiply this by integrating factor, what will happen? Directly doing x cube into y is x cube y, x cube y cube by 3, x cube into x square x power 5 by 2. Multiply this by x cube, 1 by 4 is as it is, x multiplied by x cube, x power 4 multiplied by y square dy is equal to 0. So after multiplying this differential equation by this integrating factor, this equation, this coming equation will be exact differential equation. If it is exact differential equation, then you can solve using standard format of solution of exact differential equation, or you can check it whether it is exact or not. Okay, but this in the examination it is not required. This is n, small n, del n by del y is x cube, then x cube y square, because 3 will get cancelled, derivative of this will be 0, derivative of this with respect to x, 4x cube means x cube c, x cube are same after taking derivative, and derivative of this with respect to x is 4x cube y square, here 4x cube y square, and this due to this 4, okay, this 4 will get cancelled, and derivative of this is what? 4x cube. Is del n by del y equal to del n by x, is it? Now, the solution of differential equation, how to write? Integral of m with respect to x is small m, keeping y constant, and the terms in n which are free from x. Free from x equal to c. Now integral m keeping y constant, m is x cube y plus x cube y cube by 3, x power 5 by 2 dx plus terms in n which are free from x. See, how many terms in x which are free from x? N containing 2 terms, first term and second term, and both the terms containing x, therefore there is 0 term in n which are free from x. Integrate this with respect to x keeping y constant. Integration of x power 3 is x power 4 by 4. Y is multiplicative constant. Y cube by 3 multiplicative constant here. Integral of x cube is x power 4 by 4. Integral of 1 by 2 is as it is. Integral of x power 5, x power 6 by 6 is equal to integration constant. Now x power 4 by 4, y is there. x power 4 y cube by 12 and x power 6 by 12 is equal to c. So this is the solution to this differential equation. You can multiply by it by 12 also, because 12 is the LCM and you can multiply it by 12. Okay, that is for you. Now, the fourth type of reducible to exact we are going to discuss. It is same as that of the previous one. In differential equation of the type m dx plus n dy equals 0, if fy, this is fy is equal to del m by del x minus del m by del y by m is a function of y alone or a constant, then integrating factor is e power integral of fy dy. E power integral of fy dy. Once again I write e power integral of fy dy. This is fy. If fy is a function of y alone or constant, then you can use this integrating factor for it. Here, we are going to solve this problem. See, this is our m, this is n, this is n. I am separately writing here. M is 2xy, directly writing e power x into y log y, and n is e power x. Del m by del y equals derivative with respect to y, 2x. E power x is multiplicative constant, derivative of y log y. See, derivative of y log y I am taking separately. We have the product of two terms of y. Therefore, use product rule of the derivative. Y multiplied by derivative of y, log y is 1 by y. And log y is a second function and derivative of y is 1. Then y gets cancelled. 1 plus log y is derivative of y log y. You can write directly in the example. 1 plus log y. Del n by del x is derivative with respect to x, derivative of e power x is e power x. Here del n by del y is not equal to del n by del x. Therefore, given equation is not an exact differential equation. This is equation 1. Therefore, 1 is not an exact differential equation. If it is not an exact differential equation, then integrating factor we have to use. See, initially the identification of the type of differential equation is important. Suppose this differential equation is given to you, and we are going to check whether it is exact or not. These two values, del m by del y, del m by del x are not same, therefore it is not an exact equation. If it is not an exact equation, then our try will be to find out integrating factor so as to convert this into exact differential equation. But we have limited time to convert it into exact differential equation, and for them integrating factors are also available. Now first integrating factor is what? 1 by mx plus ny. Can you use this integrating factor? This integrating factor is for homogeneous differential equation. Is it a homogeneous differential equation? No. In each and every term, power of x, degree of each and every term is not same. This formula 1 by mx minus my can you use? No, because this is not of the type f1 xy y dx plus f2 xy x dy. This differential equation, given differential equation, is not of this type. That this formula we cannot use. Or in short, but it is not a strict rule which I am going to tell you, but you may, it is restricted to the syllabus of engineering mathematics 2 of SPQ now, and it is restricted to the SPQ syllabus. So roughly I am telling you, it is not a rule. When differential equation containing transcendental function, transcendental function means exponential function, trigonometric function, log function, inverse trigonometric function. If those kind of functions are present, so I would recommend you not to use these two formulas. Then I'll check whether fx is a function of x alone or not. The fx is what? Del m by del y. Del m by del y is 2x plus e power x plus e power x log y. Okay, this is del m by del y. Minus del m by del x is e power x. This divided by n. N is e power x. Now, this e power x gets cancelled. 2x plus e power x log y divided by e power x. Now, fx we have simplified up to this step. And if you look at this value carefully, it is not a function of x alone. Because log y term is there, y term is present. Fx is not a function of x alone because y term is present. Therefore, we can write like this: fx is not a function of x alone. If fx is not a function of x alone, can you use this formula? No, we cannot use this formula. We cannot use this formula. It's all this cross-checking is not required in the examination. Now I am going to check whether fy is a function of y alone or not. Okay, in continuation, this differential equation is given. This previous three formulae we checked. Okay, it doesn't fit here. Now fy I am going to calculate. Fy is del n by del x minus del m by del y by m. This I am going to check whether fy is a function of y alone. Del n by del x to e power x, del m by del y previously we have calculated. This is del m by del y. Okay, on previous sheet I have written. This divided by 2x plus e power x log y multiplied by y. So try to simplify it fully. If some cancellation are there, that is way to perform. E power x minus 2x multiplied by minus 1 minus e power x log y. It is simplified fully. 2x plus e power x log y outside of the bracket y is present. Now e power x, e power minus x has gone. The two terms are remaining. Yes, minus is common. If anything is common, just you take out. Because finally, the reduced form of fy I want 2x plus e power x log y as it is in the denominator, y is as it is in the denominator. If you look at this one, fy, so this bracket is same. So this bracket is going to cancel. So what is remaining? Minus 1 by y is remaining. Now fy we have solved up to this, and this is a function of fy is a function of y alone. X is absent. Therefore, integrating factor e to the power integration of fy with respect to y we can use. E power fy is minus 1 by y. Minus is outside, integral of 1 by y is log y. This minus 1 can be brought here by law of logarithm, and y to the power minus 1. E and log will disappear. Y to the power minus 1 is 1 by 1. So this is the integrating factor we have calculated. Now multiply given equation by integrating factor. What I am going to do? Multiply 1 by integrating factor, and integrating factor is 1 by y. If you multiply this by 1 by y, what will happen? 2x by y. I am multiplying this by 1 by y, only 2x will remain. Okay, if you multiply this by 1 by y into 1 by y will get cancelled. This term is remaining. y multiplied by 1 by y and e power x by y dx. So when you multiply this equation, given equation by integrating factor, so this will be an exact differential equation. Okay, this will be an exact differential equation. And how to find out the solution? This is small m now. This is small n. When you find solution of exact differential equation, m and n you have to select from exact differential equation. The integral of m dx. What is m? 2x plus e power x log y. And terms in n which are free from x, n containing single term and it contains x. So there is zero term in n which are free from x equal to c. Now integration of 2x with respect to x is x square, keeping y constant. See, log y is constant and integration of e power x with respect to x is e power x. So this is the solution of this differential equation. Okay, now it's very quickly. The next problem we are going to solve. Here again m dx plus n dy equal to 0. Here log term, transcendental term is present, 1 by mx plus ny, 1 by mx minus ny. I will not prefer to use. You can check whether fx is a function of x alone or not. So when you solve fx, then it will not be the function of x alone. Okay, the f of y, because without checking I am going to find out the value of fx. I didn't check, but the value of fy I am going to find. Then you can go for finding the value of fx and you please check whether fx is a function of x alone or not. Now it is what fy is del n by del x. Del n by del x. Here I am writing del n by del x n x minus log y and del n by del x derivative with respect to x is 1, derivative of log y is 0. M is y log y and derivative of m with respect to y, use product rule, and earlier we have done it. Derivative of y log y is 1 plus log y, and you can write down directly in the examination. Derivative of y log y is 1 plus log y directly. But these two are not same, therefore this is not exact equation. Not an exact equation, this differential equation, because del n by del y and del n by del x are not same. The fy I am going to find. What is del n by del x? 1. Del n by del y 1 plus log y divided by m is y log y, and try to simplify it. 1 gets cancelled, minus log y will remain, and y log y is already there in the denominator. Again y log gets cancelled, minus 1 by y is remaining. So this is a function of y alone. Fy is a function of y alone. Okay, you can check whether fx is a function of x alone or not. That I have not done here. Okay, that is for you. But I tell you, fx is not a function of x alone on simplification. So multiply, find integrating factor. Integrating factor e power integration of fx. I think same here. Minus 1 by y and here again minus 1 by y. So integrating factor directly writing is 1 by y. Okay, because same thing we have solved. Same thing we have solved in the previous problem. Now once you get integrating factor, multiply equation by integrating factor. Multiply given equation by integrating factor. Integrating factor is 1 by y. Multiply this by 1 by y. The given equation becomes 1 by y log y dx 1 by y x minus log y dy equal to 0. Multiplying this by 1 by y. This y gets cancelled, log y dx and x by y minus log y by y. Now this is an exact equation. This equation is an exact equation. When you multiply non-exact equation by integrating factor or the correct integrating factor, you get exact equation. And once you get the exact differential equation, you can find out the solution. The solution of differential equation will be what? This is m, small m and small n we are using for exact differential equation. Remember, integral of m with respect to x, m with respect to x, and the terms in n which are free from x, n containing, now this n containing two terms, x y by n minus log y by y. But this term containing x, which is not of any use, don't write. Second term does not contain x, but that term we have to write, log y by y. Now integration of log y with respect to x is log y into x, because log y is constant. Integral of constant is of constant multiplied by that variable, minus integration of log y by y, minus I have taken outside, integration of log y by y. How do you get integration of log y by y? I am writing it. Integration of log y divided by y. See, derivative of log y is 1 by y. Substitute log y is equal to t, and derivative of log y is 1 by y dy. Derivative of t is dt. Is log 1 by y dy is dt, and log y is t, and integral of t is t square by 2, and finally value of t we can put. This integral square, integral of log y by y is log of y whole square by 2. Integral of this is log of y whole square by 2. The integral of log y by y I have solved separately, equal to c. Now this is the solution of this differential equation. So very quickly, only hint I am giving to this problem. This is m, this is n, del m by del y I am writing derivative of m with respect to y, derivative of y cube is 4y cube, derivative of y raised to 4 is 4y cube, means 4 into 3 is 12. Derivative of y with respect to y is 1 and 2x is multiplicative constant. I am writing directly. Del n by del x, derivative with respect to x, keeping y constant. Derivative of x cube is 3x square, 3 into 2 is 6. Y is multiplicative constant. Derivative of x square is x cube by 3 with respect to x. So these two are not same, therefore it is not an exact equation. Okay. Del m by del y is given equation is not exact. Is not exact. Now try to convert it to exact equation. Means it comes under the reducible to exact. 1 by mx plus ny formula you cannot use because degree of each and every term is not same. Degree of this term is 6, degree of this term is 2. Degree of each and every term is not same. 1 by mx plus ny we cannot use. 1 by mx minus ny I will not use because in each term degree of x and y must be same. Here in this term, if you consider the first term, degree of x is 2, but degree of y is 4. Degree of x and y is not same in each term. Therefore, it is not of the type f1 xy y dx plus f2 xy x dy. Means 1 by mx minus ny will not use. Then coming to fx, you try to check whether fx is a function of x alone. And I am not going to check, but you can check for your satisfaction. Fy I am going to find. Fy is del m by del y, del n by del x, 6x square y cube minus x cube by 3. This is del n by del x minus del m by del y. See, del m by del y, 12x square y cube plus 2x. This divided by m is 3x square y raised to 4 plus 2xy. Okay, try to solve it for you. Fy here del n by del x I am going to check it once for you. Derivative of x square is what? 2x. I have written integral of this. Okay, it was my mistake. Derivative of x square is 2x, not x cube by 3. Derivative of this 6x square y cube, it is okay. Derivative of x square is 2x. Derivative of 6x square y cube, and here 2x I have to write. Now 6x square y cube minus 12x square y cube is x square, no? Yes. 6 minus 12 is minus 6x square y cube minus 2x minus 2x minus 4x. In the denominator, if anything is common, you can take, because xy is common, I am taking xy common. 3x y cube plus xy I have taken common, no? Yes. Now, if anything is common in numerator, you can take again common. In the denominator, I have taken xy common, that we have done. 3xy cube plus 2. Same thing. Here, minus 2 is common, that I am taking. X is common, also I am taking common. X. Then if you take minus 2x common from here, 3xy cube. From minus 2x, minus 4x, minus 2x I am taking common, plus 2. Now, if you look at these two brackets are same. They are going to cancel. And x is also being cancelled. So what is remaining here? Minus 2 by y is remaining. And it is a function of y alone. Therefore, integrating factor formula e to the power integral of fy, this is fy, dy, this you can use. Minus 2 is outside, integral of 1 by y is log y, and this minus 2 will come here at the index place of y, and this is y raised to minus 2, and it is 1 by y square. So 1 by y square is an integrating factor, and if you multiply given equation, this is equation 1. This is equation 1 square. Multiply equation 1 by integrating factor 1 by y square, then the resulting equation will be an exact differential equation, and that part I am leaving for you. Multiply this by integrating factor, exact equation you will get, and try to solve. This is about the reducible to exact differential equation type 3 and type 4. We stop here. Thank you very much.